We have the points -3, 2, 10, 7 on a coordinate plane, and I want to know what the vector r is from the first point, -3, 2, to the second point, 10, 7. That's the first question I'm going to ask you to do. There are subsequent questions. I'll go over those, but then we'll deal with them one at a time, giving you time to think through them. Okay, so here we have a point that will designate x1, y1, another point that will designate x2, y2, and we're asking the same thing, except this time, of course, we're going to calculate the r vector in symbols, the symbols being x1, y1, x2, y2. And we're going to call that vector r12, the vector from from point 1 to point 2, x1, y1 being point 1, x2, y2 being point 2. So what's the vector from here to there in symbols? Then, next question, what's a unit vector in the direction of r? Of course, this being the r vector. And then in symbols, it'll have to be in symbols because we haven't specified the actual values of the coordinates, a vector in the direction of a unit vector in the direction of r12. So now answer at least the first question. If you can't get to the answer for the second question, we're going to stop after answering this, and the answer to this question maybe give you insight into how to do this. Then once we have these two, we can answer this question and then this question. We'll do each one separately, giving you time to think. So what's the vector r from this point to this point? Okay, well, I've drawn a few things in here, so just because this is a very straightforward question. Here's the r vector, and we can calculate its components, which are sufficient to define the vector, just by drawing the triangle whose legs are parallel to the x and the y axes, and it's very easy to see that this one has that the leg in the x direction is 13, the leg in the y direction is 5, so that the r vector is 13 times the I vector plus 5 times the j vector. And that's a very simple and concise way to express the vector. And of course, I expect fully that you understand the I and the j vectors by this point in this course. If not, go back to the first chapter of the text and review it. You can also specify the vector by specifying its angle and its magnitude. Magnitude being represented by just the letter r without the arrow over it. And that the angle is arctangent of 13/5, and the magnitude is 13 squared plus 5 squared. Now, can we go on and in terms of x1, y1, x2, y2, express the vector r12 that goes from x1, y1 to x2, y2? Now, there are a number of ways to do this. You can use a formula, but the formula doesn't have any visual relation, and the picture is every bit as simple as the formula, so I recommend the picture for this. If the r vector is here, then we draw the legs parallel to the x and the y axes and figure out their lengths and actually the directed length of each of those legs. Matter of fact, we could probably want to say, okay, we want to figure out the direction and length from here to here, and the direction and distance, let's say, from here to here. So if you haven't done that, go ahead. But I'm going to go ahead now, and it's very clear that this leg is x2 minus x1, and this one is y2 minus y1. So that the vector r12, and you pause if you haven't already written out the vector. You should look back here and think about what I said. You should do this before I do, so that I'm just telling you what you already know. So that the r vector, and this is, we're calling this vector r12. The vector r12 is x2 minus x1I plus y2 minus y1j. Again, this is not something that you should, at least I don't recommend that you regard this as a formula for the vector between x1, y1, and x2, y2. This is something that just follows very simply and immediately from this picture. And we can also find the angle theta and the magnitude r. theta is the arctangent of what? The y component over the x component. That's y2 minus y1 over x2 minus x1. And you should write down the magnitude. I'm going to pause a second and write that down before I come back, because I'm just going to block you if I write it anyway. Okay, well, the magnitude, as we saw, is y2 minus y1 over x2 minus x1. Did I say magnitude? That's the angle. In any case, the magnitude, just by the Pythagorean theorem, is the square of this plus the square of this. Well, the square of the magnitude is the square of this plus the square of this. So the magnitude is the square root of the sum of these squares. And that's something that I expect you already know quite well. Now, let's go to the question of the unit vector in the direction of r and the unit vector in the direction of r12. Okay, you should understand that the unit vector in the direction of any vector is just that vector divided by its magnitude. R with the arrow over it standing for the vector, R without the arrow over it standing for the magnitude of the vector. In this case, the vector is 13i plus 5j. R is the square root of 13 squared plus 5 squared. 13 squared is 169, 5 squared is 25. They add up to 184. 194. Okay, I'm going to fix that. Okay, 13 over all this over the square root of 194, and that's going to be 13 over the square root of 194 plus 5 over the square root of 194. Officially, you would want to rationalize this. 13 times the square root of 194 over 194, 5 square root of 194 over 194. But inasmuch as you're probably going to, in most cases, end up approximating this, you can just calculate it the way it is. So I'm not going to write that out, at least not just yet. Okay, over here, so what are we going to do here? Well, you probably want to pause and see if you can answer that. Quick hint, it's going to be the vector divided by its magnitude. R12 vector divided by R12 without the arrow, meaning the magnitude of R12. And what you wrote down for the vector ought to be this or something that would lead immediately to this. You might have written the x2 minus x1i plus y2 minus y1j all over the R12, the square root. But I went ahead and broke it into the components so we can clearly see what the x component is and what the y component is. Now, Coulomb's law says that the magnitude of the force between two charges, Q1, Q2, separated by distance r, is given by F equals K times Q1, Q2 over R squared. So we're going to apply that to the expressions that we've gotten here and see if we can find the vector that represents the force between two charges. So we could put a charge Q1 at this point and Q2 at this point. Okay, we're going to do that in a separate video. We'll break this one here, but you might want to think ahead to that and see if you can anticipate what we're going to get.